In this video, we will evaluate limits of the type f of a plus h minus f of a over h using derivatives. Now, we all know at this point that the derivative of some function f of x, so if I were to ask df by dx, okay, um, we know that that derivative is limit as h approaches 0, f of x plus h minus f of x all over h. Okay, so essentially what you need to realize is that this limit that we're trying to evaluate, which is this limit as h approaches 0, f of a plus h minus f of a all over h. If you come across things of this sort, all you're doing essentially is you are calculating the derivative, okay, first in general, and then you're replacing x with the value a. Okay, so let us use this in an example and let us ask how to, what this actually really means. So let's first evaluate limit as h approaches 0 sine of pi over 4 plus h minus sine of pi over 4 all over h. So if you look at this, okay, and just kind of ignore the pi over 4s for a second and replace the pi over 4s with x's, okay, do you see that this is nothing but the derivative of the function sine of x? Okay, so essentially to calculate this, all you need to do is differentiate the function sine of x, okay, find the derivative of this, and then evaluate this at the value x equal to pi over 4. Okay, so let's go ahead and do this. So the derivative of sine x is essentially cosine of x, and now we are going to evaluate the value of this at the at x equal to pi over 4. So this gives us cosine of pi over 4. So all this becomes that. And so this essentially is equal to 1 divided by square root 2. Some of you also like to remember this as square root 2 over 2. They're both identical. Nothing wrong with writing it in either form. Okay. Let us take another example and let us see if we can identify this. So let's take something like this. Limit as h approaches 0 ln of e plus h over h. Okay, and also let's divide everything by h. Now, when you look at this at the first attempt, right? I mean, you don't see a derivative here. But if you were to use the power or one of the rules of logs, you would recognize this easily as being a derivative. And the rule we'll use is that ln of a divided by b is equal to ln a minus ln b. So let's rewrite this as limit as h approaches 0, ln of e plus h minus, oh, actually, sorry, this is supposed to be e here. So ln of e plus h minus ln of e all over h. Now in this form, you can immediately recognize that this is some kind of a derivative, okay? And again, once again, like in the previous problem, if we were to replace all our x's with e's, you would see that this would simply be the derivative of the function natural log of x evaluated at x equal to e. Okay, so we can write this as ln x prime evaluated at x equal to e. So what does this become? 1 over x, and we're going to evaluate this as at e, and this becomes 1 divided by e. So this limit essentially is simply 1 over e. And here we've used derivatives to figure this out. Okay,